All right, everyone, and what we're going to do is we're going to take what we learned at the end of the last screencast. So if you haven't watched the one on graphing elasticity, make sure you watch that one before this one. But we're going to take what we talked about at the end of that, and which was the fact that on a demand curve, that as you move down the demand curve this way, you actually get more elastic. All right. So we're going to take that idea, you'll see it again in a second, and we're going to think about how that affects revenue for a firm. All right. So demand elasticity changes along the demand curve. Well, who would care? Well, elasticity is related to the total revenue that a firm will get. So if firms are interested in increasing their total revenues, and we're going to talk about profit maximization and things like that later on, but right now let's just think about revenue. All right. So if firms are interested in increasing that total revenue, they need to know whether to increase or decrease price to increase revenue. Total revenue equals price times quantity. So graphically, this is the rectangle connecting the origin and a point on the demand curve. So this is going to be a rectangle. You'll see it in the graph there. But what we'll see is that there'll be times when increasing the price, right? Let's do an up arrow there. So increasing the price will actually lead to a decrease in the quantity purchased, and that will actually make total revenues go in one direction. It depends on the elasticity, all right? So again, it depends on, is the increase here bigger than the decrease here in terms of percent change, and that's exactly what elasticity is. So on this graph, on this table, I'm showing you a demand curve, and that demand curve has this equation. The quantity demanded, or the horizontal axis value, equals 5 minus the price. All right, and so that's just the equation of a line, a simple line. So if you give me a price, I take 5 minus that price, and that tells me the quantity demanded. All right, and again, recall the elasticity formula is percent change in quantity demanded over percent change in price. Okay, so let's start out here with a price of 5. If I take a price of 5 and I plug it into this demand equation, I get 5 minus 5, so the quantity demanded is 0 when the price is 5. What's total revenue? Well, it's just price times quantity. 5 times 0 is 0, and so we don't have any changes yet. We're just starting at our original bundle, so that's all we have so far. All right, so now let's change the price to 4. All right, so if we plug 4 here into our demand curve, we get 5 minus 4, which equals 1. So at $4, we get a quantity demanded of 1. All right, what's the total revenue? Well, it's just price times the quantity, which is 4. And so now we have a change, so now we can look at how things have changed. So the percent price change here, going from $5 to $4, is 22%. The percent change in the quantity demanded is 200%. So if we plug those into this elasticity of demand formula, we get negative 9.1, highly, highly elastic. For a $1 change in price, we got a huge change in the quantity demanded in terms of the percentages. Okay. All right, what about for the next one here? So here we now lower the price again to $3. So 5 minus 3 is 2, so we get a quantity demanded of 2. What's the total revenue? Well, it's just the price times the quantity demanded, which is 6. So now let's change the price from $4 to $3. That's a 29% decrease in price. The quantity demanded goes from 1 to 2. That is a 67% change in the quantity demanded. All right. For an elasticity of demand, when we plug these two into the elasticity formula of negative 2.3. So it's relatively elastic. Remember, more negative than negative 1 is more elastic. All right. So now let's change the price to 2. 5 minus 2 is 3. You guys are probably getting the hang of this. I don't need to probably go through each individual one. So if we plug 2 here into the demand equation, we get 5 minus 2, which is 3. So a price of 2, quantity demanded of 3. 2 times 3 is 6. All right. So now we get a price decrease of 40%. Going from 3 to 2 is 40%. Going from 2 to 3 is a 40% increase in the quantity demanded. And if we plug 40 and 40 into this, we get a -1. This is that unitary elastic case. All right. And again, we keep going with the table. Price is -1, quantity is 4. That's a revenue of 4. 67% change in price, 29% change in quantity demanded, -0.4 elasticity of demand. Now notice we're relatively inelastic. We are at negative. We are closer to 0 than we are -1. We are in between that. All right, getting more positive with the number. And then at a price of 0, the quantity demanded is 5. So the revenue again is 0 because you're not making any money off of it. So what we saw in this previous table is that revenue is related to elasticity. Revenue is maximized at the unit elastic point on the linear demand curve. Right? That was the point at which we had the highest revenue. All right? So we can show the trade-offs of changing prices for a firm on a graph. All right? We can increase the price and we raise the price per unit, but we sell less units. If we lower the price per unit, we sell more units, but the total revenue goes down. So here's a case where we have a demand curve. And we're going to start at the top. Okay, so we're going to start at $4. We're going to lower the price to $3. All right. So when we were at $4, I can show you here. When we were at $4, we were selling 1 unit of the good. The quantity demanded was 1. Now we're at $3. The quantity demanded is 2. All right. So the revenue that we lost by lowering the price, we now get less revenue, right? So the revenue we lose is actually this area here. We lose this dollar. All right. The revenue that we gain is all of this blue area. We gain $1 here, $1 here, and $1 here. So overall, by decreasing the price $1, we gained $2 in revenue because the increase in the quantity demanded was bigger percentage-wise than we had to lower the price. So we're now making more money overall. So here we are going to lower the price from $3 to $2, and that is going to increase the quantity demanded from 2 to 3. All right. So this is the decrease in price. This is the increase in the quantity demanded. So we lose $1 for each of the units of the good. We lose $1 here by lowering our price. We make $1 less per unit that we sell. And now we gain $1 for each of these new units that we are selling. So we lost $1 on the old units that we were already selling, but we gain $1 on these new units. All right. So there's no change in revenue. The dollars you've lost by lowering the price are offset by the dollars you've gained by lowering the price. And here's the last case. So here we have a case where we start at $2. We're going to lower the price to $1. All right. So we were selling 3. The quantity demanded was 3. Now maybe we're selling 4. All right. So we lose $1 on all these goods that we were selling before. We were selling 3. We're still going to sell those 3, but we're going to get $1 less for each of them. So we lose those $3. But we pick up a new person who likes it at this lower price, and we gain $1 here. All right. But notice that we lose $3 and we gain $1 for -$2 in revenue. We are now in the inelastic region. So the place that you want to sell to maximize revenue, there's other considerations, but to maximize revenue is in this elastic part of the demand curve. All right, I'll see you in the next screencast.